6.3 million years ago, something collided with Brazil.
About 6.3 million years ago, at the end of the Miocene, a space object struck Earth with tremendous force somewhere in South America, probably in the territory that is now Brazil.
The impact was so intense that it melted surface rocks, launched molten material into the atmosphere, and created thousands of fragments of natural glass that spread across a vast region. Brazilian scientists have just confirmed the discovery of this tektite field, the first ever identified in the country, revealing a previously unknown cosmic event. Tektites are pieces of glass formed naturally when a meteorite or comet collides with the planet at high speed. The extreme heat melts the local soil or rocks, which are ejected into the air, cool rapidly, and fall back down as droplets or solidified aerodynamic shapes. In Brazil, these fragments were called tektitites, in honor of the state of Minas Gerais. Where they were first found, the research, led by geologist Álvaro Penteado Costa, a professor at the State University of Campinas, Unicamp, involved scientists from Brazil, Europe, the Middle East, and Australia. The study was published in the journal Geology in December 2025. Initially, researchers located the Gerais sites in 3 municipalities in northern Minas Gerais, Taiobeiras, Curral de Dentro, and São João do Paraíso, in a strip of approximately 90 kilometers. After the initial publication, new samples appeared in the neighboring states of Bahia and, more recently, Piauí. Today, it is known that the field extends for more than 900 kilometers, an impressive extent that continues to grow as new searches are carried out. Something common in other tektite fields around the world.
To date, the team has collected more than 600 specimens. They vary greatly in size. The smallest weigh less than 1 gram, while the largest reached 85.4 grams and about 5 centimeters in length. Their shapes resemble drops, spheres, ellipses, discs, dumbbells, or even spirals molded by their aerodynamic journey through the atmosphere while still hot and malleable. At first glance, they appear black and opaque, but under intense light they become translucent and reveal a grayish-green hue. The surface is dark and full of small cavities, marks of gas bubbles that escaped during rapid cooling, a typical sign of tektites, unlike what happens with common volcanic glasses, such as obsidian. Chemical tests confirm that these materials are not of common terrestrial origin. They are rich in silica, between 70% and 74%, have specific levels of sodium and potassium, and traces of elements such as chromium and nickel that vary considerably, indicating that the molten soil comes from diverse rocks. A crucial detail is the extremely low water content, only 71 to 107 parts per million, measured by infrared spectroscopy, much less than any volcanic glass, which typically has between 700 ppm and 2%. Furthermore, some samples contain lecitolurite, a form of pure silica that forms only at extremely high temperatures. Dating, using the argon method, AR/3R, points to approximately 6.3 million years ago, with very similar results in different samples, between 6.33 and 6.78 million years. This indicates a single impact event. The researchers explain that the age of 6.3 million years is considered an upper limit, since some of the argon may have come from the ancient impacted rocks.
Interestingly, the associated crater has not yet been found. This is not uncommon. Of the 6 main known tektite fields in the world, in Australasia, Central Europe, Ivory Coast, North America, and Belize, only 3 have identified craters. In the Brazilian case, isotopic analyses suggest that the molten material came from very old continental crust, 3 to 3.3 billion years old, probably from the São Francisco Craton, one of the oldest regions in South America, with granitic rocks. This helps guide future searches, which may use airborne magnetic and gravitational surveys to detect hidden or eroded circular anomalies. The size of the object that caused the impact is not yet known precisely, but the amount of molten material and the enormous area of dispersion indicate that it was something significant. Although smaller than the Australian event, which spanned thousands of kilometers, the team is developing mathematical models to estimate the energy released, the speed, the angle of entry, and the volume of molten rock. This discovery fills an important gap in the record of impacts in South America, where only about 9 large structures are known, almost all much older and located in Brazil. It also suggests that tektites may be more common than previously thought, but often go unnoticed or are mistaken for ordinary glass. In the early solar system, collisions were frequent due to the chaos of debris and unstable orbits. But today, With a more organized system, such events are extremely rare. Understanding these processes helps to separate scientific facts from speculation and to better comprehend the violent history of our planet. The Jurassites are not just pieces of glass, they are silent witnesses to a cosmic encounter that changed the geological landscape of part of Brazil millions of years ago, and now, finally, we have concrete proof of it.